Now that you know how to do matrix addition and subtraction, and you understand what matrices are used for, especially in business and economics, and if you still don't, I suggest you checking back the previous video. Right, now in today's video, we'll be going over how we can multiply matrices. When we multiply matrices, there are two ways. You can either use scalars or vectors, which are very different concepts. And first of all, what is a scalar? Well, a scalar is, let's say we have a matrix 1, 4, 2, 5. And then we want to multiply it by a scalar, which is, let's say we have 4. And this is the scalar number, basically. How we multiply scalar is pretty simple. We take 4, multiply by each of the units inside the matrix. So let's say the answer for this is 4 multiplied by 1, 4, 4 times 4, 16, 4 times 2, 8, 4 times 5, 20. And that is pretty simple. Now, moving on, we have the vector multiplication. And this is a bit more complex, right? But don't worry, you'll understand it. See, we have a vector 1, 4, a scalar, bad. Let's say we have a matrix 1, 4, 5, 7 multiplied by another matrix 2, 5, 4, 6. Right? Now, what you may think is that we multiply each of them by each other, but that's not how we do it. Basically, a very simple way to understand it is, let's say we have to multiply each row by each column. But before that, we want to make sure that we can multiply it, right? Not all vectors can be multiplied by each other. Let's say this is a 2 by 2 vector, because it has 2 rows and 2 columns. This is also another 2 by 2 vector, 2 rows, 2 columns. And when the first vector column, let me use a different color. When the first vector's column is the same as the second vector's row, that means you can multiply them. Now let's move on how we can multiply them, right? First, we denote this row as A1 and this row, let me make it clearer. Let me denote this row as A1 and this row as A2. Then let me denote this column as B1 and this column as B2. And if you want to multiply it, pretty simple, right? What we will get is for the first part, we want to multiply A1 multiplied by B1. Second part, we got A1 multiplied by B2. Third part, A2 multiplied by B1. And A2 multiplied by B2. And what does it get us? Well, let me do the working for you. 1 times 2, A1, B1, 1 times 2, plus 4 times 4. Because this is, if you don't understand, the first row, 1 times 2, then for the second, then 4 times 4, right? Now, for the first row, second column, right? 1 times 5 plus 4 times 6. Third column, third part, 5 times 2 plus 7 times 4. Here, finally, we get 5 times 5 plus 7 times 6. And you can do all the working 2 plus 16, 18, 5 plus 24, 29, 10 plus 28, 28, 10 plus 28, 28. And finally, 25 plus 42, we get 67. And that is our final answer. Right? Now, always remember that they must have the first vector must have the same column as the rows of the second vector in order to work. And just another bonus tip, the final resulting matrix will be a 2 by 2 matrix. Matrix is a 2 by 2 matrix, which is the same as the row of the first matrix and the column of the second matrix. Now let us move on to more questions, right? Practice question. Now for the first question, pretty simple. Just multiply each of them by each other. Negative 20, negative 4, negative 28, and definitely 0. That is your answer. Now, okay, using our previous concept of matrix addition, together combine, let's say 4b, 2b, 6b, right? Plus, now we know that it's a 3 row, 3 by 1, and it's a 3 by 1, so definitely we can add it by each other, right? Then we multiply the second one first, so we get 6a, 2 times 3 is 6, then 2ab, and because 2 multiply a plus 4, well, that is 2a plus 8. When you add them together, pretty simple. 4b plus 6a, 2b plus 2ab, 6b plus 2a plus 8. And that's your answer. Now, finally, matrix and vector multiplication. Now we know that this is a 2 by 2, and this is a 2 by 2, and then they have the same. So, I mean, the first matrix has the same column as the row of the second matrix, and then we can multiply. And the final resulting matrix will always be a 2 by 2 matrix. Okay. Now, what we can do, remember, we can denote row 1, A1, row 2, A2, column 1, B1, column 2, B2. Okay? So, take A1, multiply by B1, with 3 times 1 plus 1 times negative 4. Right? Then we got A1 times B2, which is 3 times negative 3 plus 1 times negative 1. Now here, we got A2 multiplied by B1 with negative 3 multiplied by 1 plus negative 4 multiplied by negative 4. Finally, we have A2 multiplied by B2, which is negative 3 multiplied negative 3 plus negative 4 multiplied negative 1. And if you slowly do out the algebra, you can get it, right? So 3 plus negative 4 is negative 1, negative 9, negative 9, well, minus 1, negative 10, negative 3, plus 16, well, we get 13, 9 plus 4, we get 13. And that is your final answer, ladies and gentlemen. And for the last one, I challenge you to try out this one by yourself. Assuming that you've given it a go, let me solve it together with you. Now, first of all, let us find out whether we can actually multiply it first. So, this one, the first matrix, let's call it A, then B, and C, right? Matrix A, 4 rows and 2 columns. 4 multiplied by 2, the 4 by 2 matrix. Second is a 2 by 2 matrix. Matrix B is a 2 by 2, matrix C is also 2 by 2. Okay, what do you notice? Can we multiply it? Well, first, for matrix A, the column is the same as the row of the second matrix of matrix B, and therefore we can multiply these two. What about matrix B and matrix C? Also the same. Column multiplied by row, the same. So our final resulting matrix, guess what? It's a 4 by 2 matrix. Matrix dimension is a 4 by 2. Right? Now that we know we can multiply, let's move on. Right? A1, B1. Okay, now what? Let's multiply this part before we multiply onto the C. Right? Multiply AB first before you multiply with C. Make it much more easier, alright? I don't want to use the A1, B1 symbols here because it will be extremely confusing, but I assume that you will understand what I'm doing. I will explain it as I go, right? So first, we take 3 multiplied by 0, A1 multiplied by first row multiplied by first column, A1 3 times 0, 2 times 2 plus 2 times 2, right? And the second one, 3 times 0 and then plus 2 times negative 6, which is the second column. First column, second column, right? Now, moving on. 2 times 0 plus 1 times 2. 2 times 0 plus 1 times negative 6. 3 times 0 plus 4 times 2. 3 times 0 plus 4 multiplied negative 6. Negative 1 times 0 plus negative 1 multiplied by 2. Negative 1 times 0 plus negative 1 multiplied negative 6. And there we get the first part. Do 6, 0, 0. This is C, matrix C. Let us simplify first before we get into multiplying matrix C. For negative 24, negative 2, 6. And there we go, we can multiply now, right? Negative 2, 6, 0, 0. And again, okay, this time I'll be using, since there are two matrices, I'll be using the A1, B1 as a guide. So this is A1, A2, A3, A4, and this is B1, column 1 B1, column 2 is B2. Okay, let's go. Now, here we get A1 multiplied by B1, which is 4 multiplied by negative 2, plus negative 12 multiplied by 0. Then now we got A1 multiplied by B2, which is 4 times 6 plus negative 12 times 0. A2, let me give more space. A2 multiplied by B1, A2 multiplied by B2, 2 times 6 plus negative 6 times 0. A3 multiplied by B1, 8 multiplied by negative 2 plus negative 24 multiplied by 0. A3 multiplied by B2, 8 times 6 plus negative 24 times 0. A4 times b1. Negative 2 times negative 2 plus 6 multiplied by 0. a4 multiplied by b2, negative 2 times 6 plus 6 multiplied by 0. Okay, and we can simplify. Negative 8, 24, negative 4, negative 16, 48, 4, negative 12. And there is your final answer. And that's how we multiply vectors and scalars or matrices.